All right, guys. So we're studying mass and weight in this lecture. Mass, weight, and densities is the next part of dynamics. Um, I hope the screen is visible to you guys. Mass and weight. So mass of an object is the measure of the amount of matter contained in it. Okay. Um, and this amount of matter basically, I'm sure you guys know the atoms and molecules concept, are very basics of physics and chemistry. Yeah. The amount of matter an object has depends upon the number and composition of atoms and molecules that make up the object. Yeah. So the more the atoms and molecules, the more the mass. Yeah. Mass is, in fact, the characteristic of an object which determines the magnitude of acceleration when a force acts on it. If force is constant, the mass would, you see, F equals ma. If in this case the force is constant, m and a are inversely proportional. M is inversely proportional to a, which is going to indicate if mass is greater, the acceleration is lesser. If mass is less, the acceleration is greater. Yeah, so these are the unbalanced forces. Then you see there are different instruments which are used to measure masses. Band balance, beam balance, and electronic balance. Electronic balance is the most common one in fruits and vegetable stores. Yeah, you can measure masses that way. Then there is weight. What is weight? Weight is the gravity or the force of gravitation. It is the pull of gravity, and it exists between any two objects, right? Uh, it depends on the masses of two objects and the distance between their centers. For example, uh, is Earth. Earth's center is going to produce force of gravity, and let's say there's an object. It's going to be pulled downwards from its center as well. So the center of every object is known as the center of gravity. Center of gravity or the center of mass. These are the two terminologies, okay? Um, Earth's gravitational fields, let's look at what gravitational fields are. Field force, so the fields of forces are the areas or regions around an object where there is force, and you can affect the, you can sort of feel the effect of that force. For example, if there's Earth, right? And Earth has gravitational pull, this region around Earth it's going to have the field lines, and those field lines, this entire region is where gravitational fields exist, and you can experience the effect of this force in these around this region. Okay, the pull gets stronger if you're closer to the surface of Earth, and it gets weaker if you're further away. This is why if you move in the outer space, you experience weightlessness, where the pull of gravity becomes zero. Gravitational field strength G is the gravitational force per unit mass. So this is the field strength. So this field strength is the strength of the gravitational field lines, and it is constant for gravity, and the weight is sort of dependent on the field strength. If you look at the formula, F is equal to mg. Now F equals mg is where g is the gravity pull, which is 10 Newton per kg or 10 meter per second square, which is the acceleration, gravitational field acceleration as well. Okay. So this is the formula. W is equal to mg because force, weight is a force. So W equals mg. And you can use the formula to figure out weight and answers. Now, what is the difference between mass and weight? Number one, mass of an object is a measure of the amount of matter contained in it, whereas weight is the amount of gravitational force. Very simple. Mass is a scalar quantity, weight is a vector quantity because the weight has a direction, a pull of gravity towards the downward side, right? So there's always a direction, it's a vector quantity. Mass of an object cannot be changed by its location, shape, or speed. You place the object anywhere in a particular gravitational field, it's going to stay the same, whereas weight changes, right? It does not remain the same everywhere. If you take the object in the outer space, weight's gonna change. Whereas mass would just gonna be the same, even if the field strength changes. This is matter. Matter doesn't change. Yeah. Mass of an object can never be zero. That's not possible. If it's an object, it's gonna have matter. Even a single atom, single particle will have its mass. Mass of an object, weight of an object can be zero. Yeah, weightlessness. Then SI unit of mass is kilograms, kg, and SI unit of weight is in Newton. Inertia. What is inertia? Inertia is a characteristic of resisting any change in state of rest or uniform motion. If an object is at rest, it's going to try to resist all the changes. It's going to try to stay at rest. If an object is in uniform motion, it's going to try to stay at uniform motion. This is inertia. Inertia of an object depends on its mass. More is the mass of an object, greater is the inertia. So if, let's say, the mass is more, the inertia is also more. Yeah. So, for example, if let's say there's a coin, you see this is a coin here, and you're trying to sort of topple the coin. You're trying to just topple it. Because the mass of coin is so small, you just push it away, it's gonna topple over. It has less inertia. You try to do the same with the glass. You try to throw it away, you try to topple the glass. It's gonna take some time. A glass full of water, maybe. Glass full is gonna take some time to get toppled over because there is more mass and it has more inertia. Similarly, if there's a small tennis ball and you try to kick it and you kick very lightly, the ball would just move because of a single kick. Assume there's a bowling ball, which is a very heavy ball. Yeah, I'm sure you guys have seen these balls of this bowling indoor sport. You kick it, you cannot, the ball might not move with a slight kick. Why? Because its mass is greater, it has more inertia. Some examples of inertia in everyday life are difference of pushing a stationary car and a stationary truck. Yeah, assume you're trying to push a car, you're trying to push a small car. It's going to be pushed easily. Then try to push that a truck. You cannot because it has more inertia. Forward and backward movement of passengers and vehicles starts or stops suddenly. One's body movement to the side when a car makes a sharp turn. One zigzag movement to avoid an elephant. Hitting a card with coin on top placed on a glass. Yeah. Then there's density. Density is defined as its mass per unit volume. M by V. This is density. The SI unit of density is kilograms per meter cube because mass is in kgs, volume is in meter cube. The resulting unit will be kg over meter cube or kg meter negative 3. This is the unit. Density of pure water is always 1000 kg meter cube. Substances that float on water have lower densities than that of water. Similarly, substances that sink in water have higher densities. Ice is slightly less dense than water. That is why ice floats over water. An iron nail is denser than water. That is why it sinks. Remember, density of ice is less than water. You need to just remember this. And why you don't have to go into the explanation. You can definitely search it up if you want to know the reasons. It's because of the pockets of spaces and the bonds created between the ice. You won't be asked to explain that. Okay. Let's see. Find the volume of an irregular shaped object. We've already studied this in the first topic, by the way, so you can just give all of this a read. And we're done with this topic as well. If you guys have any questions alongside, you can let me know on WhatsApp in the group, or you may, yeah. Otherwise, there's going to be a follow-up assignment which will be sent to you after you watch this lesson. Try to get done with that. We'll have a discussion session soon over this assignment as well.